Okay, here's our video on linear equations and the slope. So the slope is how steep the line is, and linear means we have a straight line. So here we have a straight line on a grid, and we just drew a rough graph of a grid. So how steep the line is, just think of a road, how steep the road is the slope. It's also called the gradient, and you'll hear probably the gradient a lot in science. So the gradient is the slope. And again, linear means straight. So we're going to take a straight line and put it on a graph. That's what linear equations are. Every straight line can be represented by an equation. And here's the equation and it's called slope-intercept form. So I'll write the equation. This is how we'll write the equation. And we're going to fill in these letters with numbers. So we have these variables here that show a linear equation on a graph, a straight line on a graph. The M represents the slope. Again, that's how steep the line is. The B is going to represent the y-intercept. That's where the line crosses the y-axis. Bring that over. So on this line, wherever it crosses is the y-intercept. In this case, it crossed at -1. So we would say that B, in this case, would be -1. So again, where the line crosses the y-axis is the y-intercept, and how steep the line is the slope. Now, lines will also cross the x-axis, and there's an x-intercept, but we'll talk about that in another video. So again, there are different forms that we can represent this line. Again, I said we have the slope-intercept form, which is this. And there's also standard form, which I'll go over later. So for now, we'll just talk about the slope-intercept form. Okay, so in slope-intercept form, again, remember, the M is the slope. It's also the rate. It's the slope of the line. It's also the gradient. The X is the independent variable, which we'll go over. The Y is the dependent variable, and again, the B is where the line crosses the y-axis. It's the y-intercept. So let's take an example here. So here we have a straight line on a graph. So here you can see the equation. I'll make it bigger. So this is saying y equals 3x plus 1. Y equals 3x plus 1. Remember, the 1 represents the B. It represents where the line crosses the y-axis. There it's crossing right there at 1. That's why we have 1. The slope is 3. That means that from 1, from where it crosses, it's going up 3, 1, 2, 3, and over 1. And it's doing that forever. Up 3 over 1. So if you had a slope, just so you understand slope, remember M is slope. So if the slope was 3, that means that it's going up 3 and over 1 all the time. It's 3 over 1. Remember, when we have whole numbers, we always put a 1 under it. So the y is going up 3 each time on the y-axis and over 1 on the x. We call this the rise over the run. Let's go back to the graph. It's going up 3, 1, 2, 3, and over 1. And it's doing that all the time. It just keeps doing that. 1, 2, 3, over 1. 1, 2, 3, over 1. Again, from here it'll go 1, 2, 3, over 1, and it'll keep doing that. And it's doing the reverse going down. It's going down 3, 1, 2, 3, and over 1 this way. 1, 2, 3, over 1. And you can see every time you do it, it goes on the line. So that's what a slope means. This slope means it's going up 3 over 1. Rise over run. So let's say the slope was 5. What does that mean? That's going up 5 over 1. And if the slope was, what if the slope was 2/3? It's going up 2 over 3. Rise is the y, and run is the x. Rise over run. Okay, so Now in your textbooks in high school, you'll see this symbol, delta, delta y over delta x. And all that means is the rise over the run. It's just a fancy way of saying rise over run. When you see delta y, delta x, it says the change in y over the change of x. So if I said 5/7, it just means that the change in y is 5 each time. It's going up 5 each time, and it's going over 7 each time for the x. So when you see delta y, delta x, it just means the change in y over the change of x. It also means rise over run. So it's the slope. So if the slope was 3/8, what does that mean? It's going up 3 over 8. Sometimes you can have a negative slope. So you had this. That means it's going down 3 and over 5. So anytime you see a negative slope, it's going down the line. Anytime you see a positive slope, it's going up. So this slope is positive because from left to right, it's going up. You know it's positive also because the slope is positive. If this line going left to right was going down, then it would be a negative slope. And it would be a negative line. Positive slope, positive line. Negative slope, negative line. Okay, so if I saw this equation here, right, and I'll write it better. It says y equals 2x minus 3. We know it's a positive line. First of all, from left to right, it's going up. The only thing missing here, and you'll get points taken out, is there's no arrow. There should be arrows on linear equation lines. Not always, though, and we'll talk about that in other videos. You won't always have a straight, solid line. Sometimes you're going to have dotted lines. But again, we'll talk about that. So here's the equation. Y equals 2x minus 3. We know the slope is 2. And we know the y-intercept is negative 3. And here's where it starts. It's going to cross the line at negative 3. And the slope tells us everything. It's going up 2, 1, 2, over 1. Up 2, 1, 2, over 1. And it continually does that. Up 2, over 1. Up 2, over 1. So the change of y over the change of x, the rise over the run, is 2 over 1. Positive line. So what type of line do you think that is? Remember, when you make lines, don't forget those arrows. We know that this is negative y. Going left to right, it's going down. Okay? So here's our general way of writing it again. Y equals mx plus b. We know that m is the slope. We already know b. There it is. It's crossing at 1. So this will be y equals mx plus 1. Now we just need to find the slope. We know it's negative. We know the slope is negative, so we can say that. But we need to find the slope, and here's a way of doing it. First of all, you can, if you look at the graph and you see it's going down to the, how far is it going down to get to the next line? You can do something like that. So if we go down 1, 2, and over 1, 2, 3, it seems like we hit the line. But let's make sure. So here's a way of getting the slope. You need 2 points, 2 pairs on the grid. So here's a pair right there. We know that pair. That pair, remember x comes first, so x is 0 and y is 1. That's a pair. X is 0, y is 1. So you can use any point you want, any pairs you want that are on the line. Right? So we can use anything. Here we have, and you probably want one where it goes evenly on the line, where you're not using any fractions. And you can use fractions if you want. So it looks like over here we have a negative 3 and a 3. Looks like that works. So then we have a slope of the x is negative 3 and the y is 3. So here's our 2 pairs. So this is how we do it. Take the 2 pairs, and we're going to make this formula. And I'll write the formula over here. The formula is, by the way, the change of y over the change of x, which is rise over run. Now it looks fancy, but the m is going to have, we're going to use two y's. That's why you have these subscripts, y2, y1. They're not exponents, they're subscripts. We're going to take 2 of the y's and divide it by 2 of the x's after we subtract. So again, remember we had these 2 points. We had a 0, 1, and we had a negative 3, 3. So let's write it over here. It doesn't matter which y you use. Remember, x comes first, then y, x, then y. So if, let's say we use this y, this 3. So we're going to say 3 minus that y, 1. Now we could have done y minus 3. Doesn't matter. But if you use this y, you have to use its partner. Its partner x is a negative 3. So for the x part, right here, we're going to use negative 3 minus 0. Do not do this. Don't do 3 minus 1 and then 0 minus 3. You're mixing the partners up. Keep the partners the same. So 3 minus 1 is 2. And negative 3 minus 0, well, anything minus 0 is still negative 3. So the slope is negative 2/3. The whole thing is negative. Let's go back here now. We know it's negative because it's going down. So we know we have to have a negative slope. So then it's y equals negative 2/3 x plus 1. That's the equation. This equation represents that line on the grid. So again, the y is going down 2 over 3. 1, 2, 1, 2, 3, like we said before. And it's continually doing that. It's going down 2 over 3. Down 2 over 3. And it crosses at the 1. Let's do another one so we understand how to get slope. Let's say I just gave you these two pairs. How would you get the slope? So what's the change of y over the change of x? What is the rise over the run? Right, that's what slope is. We'll get m. So how do we get it? Remember the formula. We need 2 y's. And we need 2 x's. Any ones you want. Do you want to use that y or do you want to use that y? You'll get the same answer as long as you don't mix the partners together. So let's use this y. 3 minus 6. 3 minus the 6. Remember, y minus y. Okay, so if we're using this 3, we have to use that 2 now. 2 minus 9. And that'll give you the slope. So what is the slope? What is m? Remember, keep change, change. This will be 3 minus, so it would be 3 plus negative 6. That's what that would turn into. So we'll have a negative 3 on top there. And this will be 2 plus negative 9. And we'll have a negative 7 there. Anytime you have a negative and a negative together, you'll get a positive. So the slope will be 3/7. That's the slope, 3/7. So on our equation now, we can say, for these 2 points, we're saying y equals 3/7 x plus b. That's how we got the slope. Now we can figure out this equation also by just plugging in whatever x and y are. And we have what x and y are, is. We know we can use, let's say we have that x is 2. If x is 2, y has to be 3. So y has to be 3 if you're using x as 2. Now, remember, this is saying 3/7 times x. 3/7 times 2 will give us 6/7. We still haven't found out what b is. Again, we could have used 9 and 6, and we would have got the same answer anyway. So we have a 3 equals 6/7 plus b. X is gone now because we said the x was 2. So what do? We just subtract the 6/7 from both sides, and you'll get b. Okay, and if you subtract that, b will be 15/7. 15/7. So our equation, our final equation, I'll bring this down, we'll say that y equals 3/7 x plus 15/7. That's the equation. And we know from this that the slope is going up 3/7. It's going to cross at 15/7, which is 2 1/7. That's where it's going to cross on the line. And we know it's positive because it's a positive slope. Sometimes you'll see them on input-output boxes. And the input-output box could be vertical, like this, or it could be horizontal. Now here, you can see right away the x is going up by 1 each time. The x is going up by 1. So the change of y by the change of x, well, we can see the x is going up by 1 each time. That's the change in x. And the y is going up by 5 each time. So there it is. There's the slope. The slope is 5/1. It's going up 5/1. You can say the slope is 5. On our equation here, we have y equals 5x plus b. So now what do? Plug in any x and any y, any pair you want. So when y is 5, what does x have to be? 1. So 5 times 1 is 5. You minus the 5 on both sides, and b becomes 0. So in that case, we don't even need to put anything. We just say y equals 5x. That's the equation. We created a linear equation. So we'll do more linear equations in the next video. Great job.